right triangle trig, you guys are going to be able to find angles and side lengths of right triangles. Okay, so you have this pink foldable. You want to make sure that you go ahead and do the fold, cut along the sides to expose the notes that are behind it, okay? We're not going to do all 6 together. We're only going to do a few because, like I said before, this is review. This is not the first time or the second time that you guys have seen this. Okay, so first thing you always want to make sure you do is that you label your sides of your right triangle. Okay, labeling the sides will help prevent you all from making any potential mistakes, and then of course picking the wrong trig function. Because to find an angle measure or a side length in a right triangle, you use SOHCAHTOA, which you see along the side. Okay, which you see along the side. So SOHCAHTOA stands for what? Sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. Okay, SOHCAHTOA there to help you. All right, labeling your sides helps you in determining which one of those so, ca, or TOA to use to find a side length. So remember, it's always based off of your acute angle, which is known as your reference angle. Okay, you always label your sides based off of that acute angle. Okay, X will be considered your what side? It would be adjacent. What does adjacent stand for? Or not stand for, but it means next to. Okay, so this is the side that's next to the angle, but not to be confused with the hypotenuse. The hypotenuse is always across from the what? Right. The right angle. So this 11.2 is your hypotenuse. Very good. Over here in number 2, 52 is our acute angle, aka our reference angle. X would be our what side? Opposite. And 7.4 would be our hypotenuse. Remember, it's across from the 90-degree angle. And number 3, remember we use the acute angle, never the 90-degree angle. X is our what? Hypotenuse. And this 24.6 is our adjacent. Always make sure that you label your respective sides so then that way you can figure out exactly which trig ratio we're going to use. So, looking at that, we're going to identify the trig ratio. Our reference angle for number 1 was 36. Our hypotenuse was what again? 11.2. My opposite, though. Did I put anything there? Did I label it? No. Okay? I don't want to put an X. Okay. So there's nothing on my opposite side, but my adjacent is my X. So I have hypotenuse and adjacent, which is which trig ratio? Sorry, I think I said the wrong thing. Sorry, adjacent and hypotenuse, my mistake. Cosine. Because remember, cosine is adjacent and hypotenuse A and H. Okay? This is the ca in SOHCAHTOA. Here, my reference angle is 52 degrees. That is my acute angle. My hypotenuse, which you guys labeled, was 7.4. X was my opposite, and nothing was labeled for my adjacent. So which trig function has opposite and hypotenuse in it? It is sine. Okay? Remember, it is SOHCAHTOA. We want to use the trig function that has whichever side length that we label. So O and H would be sine. And this last one, we have 22 degrees. We labeled our hypotenuse X. We had nothing labeled for our opposite, but our adjacent was 24.6. Which trig ratio has adjacent and hypotenuse? Cosine. So again, the importance of labeling your sides is key, so that way you know which part of SOHCAHTOA to use. Everyone following along? Is this review? Do you remember this? Okay. All right. So now let's write our equation and let's solve for our missing side. Okay? So what was the trig ratio that we decided for number 1? Cosine. So remember, it's always set up as cosine of your angle. So that'd be cosine of 36 degrees equals my adjacent side over my hypotenuse. So what is that? X over 11.2. Okay? Now this particular foldable sets it up as almost like a proportion. What would go underneath the cosine 36? It would be a 1. So if you wanted to, you could cross multiply to solve for x, but you don't necessarily have to. Depending on however you guys learn how to solve trig functions, you don't have to set it up as a proportion. However, if you don't remember, this is a good way. Okay? Because when you cross multiply, you'll get 1 times x, which is just x, and then you'll get 11.2 times the cosine of 36. And you already have solved for x at that point. Okay? Questions on the setup of the ratio and how I got to this last line? All right. Question. A couple of things that you're going to have to check on this calculator before you can actually go ahead and type this into your calculator, okay? So, to turn this on, there's a hold on button in the bottom left corner, so make sure you click that to turn it on, okay? All right? And you want to go ahead and make sure that because we're dealing with a right triangle that's in degrees, you want to make sure your calculator is in degree mode, okay? The graphing calculators, and even the scientific calculators, they have different modes, and they do represent different things that you guys will learn about later. Not far future, pretty near. So you want to make sure that if you're dealing with a problem that's in degrees, you want to be in degree mode. So how do you check that? You press the mode button. Mode button. All right, and then you want to go down to the line that says radian and then degree. Now, as you can see on my calculator, radian is highlighted. Okay, so I want to go down and I want to go to that line where it's flashing over radian. I want to go over to degree and select enter. And if you notice with this calculator, it will highlight red the last thing that I pressed. Okay, so you want to make sure that degree is highlighted. Is everyone's degree highlighted? Okay. If it's not, you're going to get an answer that makes 0 sense. Okay? So now I need to get out of this. Okay? And anytime you're in a program, something outside the home screen, you want to press second mode, and it takes you back to your home screen. So it basically quits out of the program. Everyone okay? All right. So now, remember we wanted to figure out, it was 11.2 cosine 36, correct? So then that's exactly what I typed, all in one line. 11.2. My cosine button is located 2 buttons above the 8, and then 36, close parentheses. Is that what we have written down on our paper? So then we click enter, and then there is the length of x. And you always want to make sure that you round to 3 significant figures. So what would that be? 9.06. So x is equal to 9.06, and there were no units. Okay. If you are not in degree mode, you're going to get a value that's in between like -1 and 1. Okay. And for a problem like this where the hypotenuse was 11.2, that would make 0 sense. So if you get something like that, then that's kind of an indication that, oh snap, I'm in the wrong mode. Okay. All right, let's look at number 2. We said the trig function was going to be what? Sine. So we'll have sine of our angle, which was 52. That is going to equal opposite over hypotenuse. What's my opposite? And my hypotenuse is 7.4. If I put a 1 underneath, then all I have to do is cross multiply. This will give me x equals 7.4 sine 52. Yes? Okay. Once you put your calculator on degree mode, it stays in degree mode. Okay? Even when you turn it off, it stays in degree mode. The only time that it will ever go back to radians if you change out the batteries or you reset your calculator. Okay? So, 9.6? What's 9.6? What am I typing in? 7.4. I don't know what I got that from. 7.4 sine, right beside cosine, 52. You guys get this? Anybody not get this? Three significant figures, what's that? 5.83. So far, so good? Now the last one. The trig ratio was, so cosine 22 equals 24.6 over x. Now this one's different from the first two. Why? X is the variable in the denominator, which means that the format is not going to be set up how it was with 1 and 2. Okay? Be very careful with these. If I make my proportion, when I cross multiply, I'll get 24.6 equals x cosine 22. How do I solve for x? Divide by cosine 22. You cannot not take 22 without the cosine, like they go together. Okay? So what x actually equals is 24.6 divided by the cosine of 22. And we type that into our calculator. 24.6 divided by cosine 22. We don't have to worry about putting cosine inside of a individual parentheses because that whole cosine 22 is one number. So it's one solid number that's being divided by. So you click enter. Did everybody get 26 number? Three significant figures would be 26 point. Very good. Questions on finding side lengths or using the calculator to do so? Okay. Okay, so you were supposed to do 4, 5, and 6. Okay. Let's see. Let's label our sides. Okay, let's label our sides. Christian. 12 was what? Sorry, I'll think. And number 4. And number 4, Christian, what was x? It was our opposite side, and 77.2 was our what side? Adjacent. So that meant Paige, what trig function was I going to use? Tangent, okay? And continue, Jana, to set this up for me. It was tangent equals 77.2. So once I cross multiply, I'll have 77.2 tangent 11. And Alexa, what did you get for your value? 15.0? Yes. Very good. Okay. All right. So we dealt with the sides. Now we're going to deal with the angles. Okay. Whenever you're solving for an angle, it even says along the side of your foldable, it says inverse trig function. Anytime you're looking for an angle, you always want to use the inverse of your trig function. So you'll still set it up the same way. You'll still label your sides and identify which trig ratio you're going to use. Except this time, x, or your unknown, is your angle. And the only way to separate the angle from its trig function is the inverse. Okay? So let's still label our sides. 12 is what side compared to the angle? Opposite. And 56 is the hypotenuse. So again, 56 is our reference angle. Oops, I lied. That's so wrong. All right. Our reference angle is theta. That is the Greek letter theta. Okay? And you just do it with a circle and just kind of keep going through. Okay? Our hypotenuse is 56. And our opposite side is 12. I have nothing in my adjacent. Which trig ratio is opposite and hypotenuse? Sine. Okay? So when we set this up to solve it, we'll still set it up the same way. Okay? We'll still set it up the same way. Sine of our angle. This time our angle is theta, it's our unknown, equals my opposite side over my hypotenuse. So again, to get the angle separate from your trig function, you do the inverse. And the inverse is when you have that little -1. Y'all remember that from geometry? Okay? And then you just type in your fraction. Okay? So in our calculator we go. I want to do the second button, which is the blue button, and then sign, because it was the sign inverse, correct? And then I just type in my fraction. Was it 12 over 56? Thank you. So I don't have to keep flipping back and forth. And click enter. Did everybody get this number? That's my angle. 12.4. 12.4. So theta equals 12.4 degrees. Okay? Question. Let's do number 2. Basing my sides off of theta. Okay? Roderick, 24 is my what side? Opposite, and 35.2 is my adjacent. So if I have opposite, which is 24, and adjacent, which is 35.2, then Dylan, what trig function am I using? I'm using tangent, okay? So I still set it up the same way. Tangent of my angle equals my opposite side, 24, over my adjacent side, 32.5. And again, because I'm looking for an angle, I do the inverse. You guys typing into your calculator? What you guys get for theta? 34.3? Yes? Okay. So tangent inverse, 24. Y'all see that? I made a mistake. I forgot the 2. These arrows right here let you go back into the problem. Right, 24 divided by 35.2. And yes, 34.3. Very nice. And this last one, based off of theta, Oshani, 45 is my what side? 16 is my what? Wait, 45 is my opposite? No, other way. No, yeah. Because you said 16, you're adjacent and opposite, and I was like, wait, what? Yeah. Okay, and opposite. Cool deal. So theta, adjacent is 16, 45 is my opposite. Opposite and adjacent make what? Tangent. So again, tangent theta equals 45 over 16. And again, anytime I'm looking for the angle, I always do the inverse. Did you guys get this? So to 3 significant figures, theta should be 70.4 degrees. Okay? Now, if you forget the degree symbol, no IB is not going to count you off. However, I will say this. If you're looking for a side length and your sides have units to them, like centimeters or meters, and you do not put centimeters or meters with your side length, then yes. Okay? So please make sure you always remember your units. Okay? Do the next 3. Take like 2 minutes. So, let's talk about number 6. Okay? You had roughly 23.5. Okay. 23.5 was our what side? And 41? So our trig ratio was sine. So we set it up sine theta equals opposite over hypotenuse. And again, because we're looking for an angle, we do the inverse. Now, when you went to type this in, what you got, right? So that's 34.971. I'm going to write this down, 34.971. When you're rounding to 3 significant figures, you always start with your first non-zero number, which is the 3, right? So that's your first significant figure, 4 is your second, and 9 is your third. So you would stop there, okay? But you need to look at the number afterwards to see if you need to round up or keep it the same. Well, that 7 is going to cause that 9 to round up, which is going to cause that 4 to round up. So when you're rounding to three significant figures, this is actually 35.0. The 0 basically is that placeholder for that third significant figure because that 9 ended up getting rounded up. Okay? So it will be 35.0. And yes, you would need that place. Questions on finding the angles in right triangles. Okay, so the last little bit is your word problem association with right triangle trig. Okay, angles is elevation, depression. And I'm telling you, hopefully the second time or third time around, this is a lot easier for you guys because you need to remember that angles of elevation and depression are always formed by a horizontal line and then, of course, the line of sight either above or below for angles of elevation, depression, respectively. Okay? Students, they tend to forget that it has to come from a horizontal line. Okay? Like the angle of elevation or depression. Now, if a car is on the ground, they can assume that the ground will be that horizontal line and then them looking up. But it's usually the depression where students tend to have an issue. The most common one is when you have a person standing on top of the building and they're looking down at a perspective, let's say a dot on the ground, and their angle of depression is 60 degrees. A lot of times students will draw in that line, but then they'll put 60 right here. Is that the angle of depression drawn correctly? No, it's not. You have to make sure that, think of it like this. Oh, the person was looking out at the world straight ahead. And then it just so happens that there was a little flicker of light on the ground that distracted them to look down. That is the angle of depression. Okay, it always has to come from some horizontal line going down, not from a vertical line. Does everybody understand that? Okay, so let's look at a few random problems from this foldable. Okay, I'll do 3 with you all, and then I want you guys to do the rest, including the 2 from the red foldable on your own. Okay? There's no pictures here. You have to draw the picture. Okay? You can be as detailed as you want to in the picture. You can be as basic. Okay? But at the end of the day, every single one of these should look like a what? What kind of picture? A what? What kind of triangle? A right triangle. Okay? So, an air traffic controller at an airport sees a plane at an angle of elevation of 56 degrees. The plane is at an altitude of 5,204 feet. What is the horizontal distance to the nearest hundredth from the plane to the airport? Okay? So, you read it once, you read it again. An air traffic controller is at an airport. Okay? So I need a point to represent the airport. It sees a plane at an angle of elevation of 56. So remember, angles of elevation always need to come from some horizontal line and then the line of sight looking up. So then that here would be 56 degrees. Now the plane, so that means the plane has to be up here, correct? So the plane is at an altitude. What does altitude mean? Height. So it's basically at a height of 5,204 feet. Height is always what to the ground? Vertical. So there is your 90-degree angle. 5,204 feet. What is the horizontal distance to the nearest hundredth from the plane to the airport? Horizontal. What's going to be my x? It's going to be the adjacent because it said the horizontal distance. Now, if it just said what's the distance to the nearest hundred from the plane to the airport, then it would have been the hypotenuse. But because it says the horizontal distance is once that bottom part. Okay? Questions on how to get the picture? Yes. No. It's always going to be on that bottom part. Okay? Yep. we're gonna solve it. So again, based off of your angle, 5,204 feet is your opposite, and x is your adjacent. Opposite and adjacent make tangent. So tangent of our angle, which is equals our opposite side over our adjacent. If I set up the proportion and cross multiply, I'll have x tangent 56 equals 5,204. So then to solve for x, I need to divide 5,204 by tangent 56. And I'm rounding to the nearest hundred. So unless it states it, you always use three significant figures or the exact answer. Got this? Then there's hundreds. What would it be? What would it be? For the decimal, yeah, right? And don't forget your units here. The pitch of a roof needs to rise 3 feet for every 14 feet of run. What is the angle of decline of the roof to the nearest degree? Okay? First off, the pitch of a roof. What does that mean? The highest part, that tip part, okay? Remember a long time ago when you used to draw your houses like this? Right? Or maybe even like this? Some of y'all still draw it this way? Okay. So the pitch is the highest part of the house, okay? And so it says the pitch of roof needs to rise 3 feet. Rise means what? It needs to go up vertically 3 feet for every 14 feet of run. Run would be your horizontal. Do you see your right triangle? Okay. So, huh? No, you don't need to graph it. I mean, you could put on for a but you don't have to. So basically, you have your rise of 3 feet and your run of 14 feet. And it's asking you, what is the angle of decline of the roof? Now, in my little makeshift house that I've created, the decline is this red part that's at the ends of the orange line. Does everyone see that? Okay. And so I'm looking for my angle of decline, in other words, my angle of depression, okay, of the roof. So the depression has to clearly come from the top going down, correct? And remember, angles of depression always come from a horizontal line going down. So technically, this is what I'm looking for. And actually, let me not use x. Let me use theta, common language. Okay? That's my angle. Question is how we got the picture. Now, theta isn't inside my triangle. Don't I need theta inside the triangle to find it? Opposite interior, also known as alternate interior. Y'all remember alternate interior angles from geometry? They're always congruent. So angles of depression are always congruent to angles of elevation. So theta corresponds, I should have made this a bigger house, corresponds to this angle right here on the inside. Because alternate interior angles are congruent, because horizontal lines are always parallel. So if your theta ends up outside your triangle, just go to this corresponding angle of elevation inside the triangle. We don't know specifically if it is or not. But we can use SOHCAHTOA to determine what angle that is. So let me do it in a clearer picture here, mostly for the video sake. 3 is what? Opposite adjacent or hypotenuse. And 14 is with trig ratio. So I'll have tangent of theta is equal to my opposite side over my adjacent. And because I'm looking for an angle, I need to use the what? The inverse. You will always see me write that final line before you go to type it into your calculator. That technically is the exact answer for theta. Okay? So let's say you don't have a calculator, grab a calculator at home, or your phone decides to stop working. You can always give me all your answers down to this point. Okay? It's the point right before you go and type into your calculator. So my angle of depression is 12.1. So far, so good? Last one we'll do together, and then I'm going to give you about 8 minutes to do the rest. Okay? Look at number 6. Number 6 is on the folded in part of the brochure. As viewed from a cliff, 410 meters above sea level, the angle of depression to a ship is 32 degrees. How far is the ship from the shore to the nearest 100? Now, let me also say this, it's a word problem. It means you got to have a little bit of knowledge of the real world, okay? Sea level is what? Like, in a picture, what would that be considered? It's on the bottom, it's the floor, right? It's the water, right? It's the water in your picture. If you have a ladder leaning up against a house, everybody knows a ladder leans, right? A ladder is never vertically along the side of the house, right? Okay. You know, just certain little things. You know, a pitch of a roof. Not too many people knew that. Now you know. Okay. So you gotta have a little bit of experience outside of, in the world. So here we go. I need a cliff. I need my sea level, and I need a ship. Okay. So hopefully you might have seen some picture of water with a beautiful, gorgeous cliff and a boat somewhere in this. Okay? We all know that cliffs, vertical drop. I think it wasn't in the class, but I said, undefined. You go off the cliff, you will be undefined. Okay. There we go. So you got sea level, and you got your boat. So our cliff is 410 meters above sea level, so this is 410. The angle of depression to a ship. I need to start at the top of my cliff, and depression goes down to the boat. But that 32 degrees, remember, always comes from a horizontal line. So this is 32 degrees, but in my triangle, it's where? Where that boat is. Does everybody see the right triangle? The cliff and the sea level make that 90-degree angle. So how far is the ship from the shore to the nearest 100? What's going to be labeled X? The sea level. 410 is my what side? Opposite, because remember it's based off of the angle, and X is my adjacent. Will it always be tangent? No, but 95% of the time it probably is going to be tangent, okay? It really is more about what the question's asking you to find. Tangent of 32 degrees equals opposite, over adjacent. Cross multiply. I'm going to end up dividing 410 by the tangent of 32. You're rounding to the nearest hundredth. So what would that be? 656.14 meters. Okay. And just real quick, I just need to double check something. Did we round? We did not round correctly here. To the nearest degree, what would it be? 12. So this one actually should have been 12. I didn't read the directions all the way through. Don't do what I did. Questions on angles of elevation or depression? All right.